This is Henry. Today we'll look at logarithm and exponential functions. And so we want to see the relationship between logarithm and exponents. Remember, when we are multiplying, remember the basic rule of indices. When you are multiplying, you simply add the powers. Therefore, you have m to the power of 3. It's turned into an exponential function via the multiplication. And if we are dividing a certain number, we are simply getting one of the base and then we are taking away the powers. When we are dividing, we take away the powers. When you are multiplying, we add the powers. And so we have an inverse of m. It's the same as saying 1 over m. And so we can switch from exponents to logarithms. Suppose you said 2 to the power of 4 is equal to, okay, we can say 2 to the power of x, so that we solve for x, is equal to 16. Remember such exponents? We could actually look at the common number here, 2. There is also 2 to the power of 4. And would say 2 to the power of x, okay, that's a power, is equal to 2 to the power of 4. Eventually, we'll just equate the powers and say x is equal to a 4. Remember such? Now suppose you want to link exponents to logarithm. You'd say, let's solve this using logarithm. And then we want to get the number 4. We would therefore say, introduce the log on both sides. We'd say, once you introduce the log on an exponential function, the power drops. On equal side, on the other side, we also introduce the log. And then we solve for x. We'll therefore say, divide both sides by logarithm of 2. What will happen is, once you get the logarithm of 16, log 16 divide by a logarithm of 2. Your answer will be 4. Try that one using your calculator. We are combining exponents, figures or letters raised to the power of a number or a letter, and then finding the equivalent using the logarithm. Okay, so we can solve any equation using either exponents or logarithm. Let's try something. Let's try. Okay. Suppose we said a log of 27. What's the value of a log of 27? Some may think of breaking this number 27. This is the same as saying 3. 3 times 9. Okay? Some can say, no, we can go further and say, this is 3 times 3 times 3. So we are just looking at the number 27. And then now we introduce the log and say, what would be the logarithm of such a number? Okay? Others would say, okay, it's the same as saying these are the same, and then add the powers that are there. It would be 3, 1 plus 1 plus 1 to the power of 3, and then when you introduce the log, we say the power drops. And so it will be like this. 3 logarithm of 3. Okay. Others will say, no, it's the same as saying the logarithm of 3, the logarithm of 3, the logarithm of 3. And then since we are multiplying, we just add. It's the same as saying this. Logarithm of 3, we are adding because here there's a multiplication sign because of the rules of indices. Logarithm of 3. Okay? It's the same as saying 3 logarithm of 3. It's the same as saying there are 3 log 3s. It's the same as saying we are doing what? There are 3 of them. Okay? Okay? You've seen. There are 3 of them. Hence we get 1 and multiply by 3. How many they are. Okay. So we can now combine logarithm with exponents and solve anything. Questions like these. A, find the value of x. Okay. Find the value of x. Equally, we can say 3 to the power x is equal to 100. Find the value of x. You would introduce the log and say, even if I was to do this, it would be the same. I introduce the log and then the power drops, it would look like this. X logarithm of 2 being equal to the logarithm of 8. Divide both sides by a log of 2. A log of 2. Therefore, the value of x is the same as dividing the log of 8 by the log of 2. You find that you get your 3. Okay, using log. Others would say, no. Already here we have a 2 to the power of x, and then a 2 can be used and raised to the power, so we can get 8. So 2 to the power of 3. So that 2 times 2, 4 times 2, 8. And then would say, since the bases are the same, equate the powers. This and this. Okay. Equally here, would say, okay, we have 3 to the power, okay, 3 to the power of what? 3 to the power of x, and then is equal to 100. Let's say if I were to introduce the log on both sides, that would mean that you drop the power once you introduce the log. You find a number, divide by the log given on the other side, and then divide both sides, so we can have the value of x. Okay, our x is therefore a log of 100 divided by a log of 3. Whatever value you find there, that's the answer. Okay. Another one. We'll now say exponents and logarithm. We can do anything. 2 to the power x plus 1 being equal to 8. Okay? We solve for x. Then we say solve for x. Okay? Others would say, okay, use the first method where you're just playing around with exponents. Others would say, use another method where you now introduce the logarithm. Okay? Method 1, method 2. I would say 2 to the power x plus 1 being equal to 8. You play around with the 8 so that you raise it to the power. Okay? Being equal to 2 to the power of 3. This is the same as that. This is the same as that. We're not changing anything. If the bases are the same, we get now the value of x plus 1 being equal to 3. And then x will therefore equal to 3, take away 1. Therefore, your x becomes your 2. Okay? If we were to use logarithm, we would say 2x plus 1 being equal to 8. Introduce the log and drop the power. Introduce the log on both sides. We'll introduce the log. And then we'll say divide that by the log of 2, divide that by a log of 2. Therefore, x plus 1 is equal to, here you have your 3. When you divide log 3 by log 2, you get 3. And so you solve for x and say x is therefore equal to 3, take away 1, your x will equal to 2. This is the same as this. So we are combining logarithm on exponents or indices, raising to the power of something, combining them to find whatever we want. Okay.